Here's a quick tutorial or explanation on how you name esters. So first of all, let's start with the general structure of an ester, which is this. And we could call this R1 and R2 for the different alkyl groups. So the way esters are named is after the way that they can be made traditionally. And just to show you this reaction that we'll come across second semester, the way that you actually make an ester is you react an alcohol with a carboxylic acid, and you end up losing water along the way. And I should make sure I get the right. You end up losing water to form the ester, and this is what's actually called, can be called a condensation reaction. And this particular reaction is called the Fischer esterification reaction. Just for completeness sake, the only thing it needs is some sort of acid catalyst like sulfuric or nitric acid. So the idea is that when you make an ester, this portion comes from the alcohol, the OR group. That's where the alcohol portion is. And then this part is from the carboxylic acid part. And so that's actually the way we traditionally name esters. We name them by naming the alkyl group of the alcohol. That's the first part of the name. And then we have the second part of the name being, it's the name of the carboxylic acid with the suffix of O of ANOATE is the suffix. So let's take something, and there can be a common name or an IUPAC name for this. Let me just take kind of a common name of something that we actually used in lab or made in lab last week. Last week, one of our products in experiment 3B was this acid. And this is called, or was this is acetic acid. Actually, this has nothing to do with lab from last week, but this is acetic acid. So if you add to acetic acid ethyl alcohol, and that's a common name for ethanol, is ethyl alcohol because it's the alkyl group, the ethyl group attached to an OH. So if I do that, I actually make this ester. And so the common name of this would actually be, we have an ethyl group attached to the alcohol part of the ester. So this would be ethyl. And then this part came from acetic acid, so this can be called ethyl acetate. That would kind of be its common name. Now, acetic acid can also be called ethanoic acid, would be its much stricter IUPAC rule. So if we said we had ethyl acetate, we could also then make the IUPAC name of this being ethyl ethanoate. So that would be its IUPAC name. So the IUPAC name would be ethyl ethanoate, but in the lab we would call this ethyl acetate. So ethyl acetate is a common solvent that's used in things like fingernail polish removers and other paint strippers. So the idea here is that there is a common name, the common names for acids like acetic acid, and there's also an IUPAC name for the 2-carbon acid, which would be ethanoic acid. So if we were to write ethyl acetate as the common name, it could also be called ethyl ethanoate, which is more of what this format would be. Okay. So a couple of examples. And I'm going to deal strictly with the IUPAC way of naming. So let's say we had this ester. The first thing we have to do is we have to name the alkyl group attached to the oxygen that came from the alcohol part. And so what is this group? If you said isopropyl, you are correct. So this is going to be isopropyl, and now we have to work on the acid part. Now, a carboxylic acid, if you look at your chart, that's the C double bond O part. That is at the top of the list, or is near the top of the list. So that means that it gets the priority in naming and it gets the priority in numbering. We always start numbering a carboxylic acid, or in this case the ester. This part, this C double bond O is carbon 1, 2, 3, 4, and 5. So we always start numbering at the C double bond O part of a carboxylic acid and at the C double bond O part of an ester. So I now have to name this part. Well, that's 5. First of all, there's a bromo substituent. So this would be isopropyl 4 bromo pent and O8. So the pentanoate is the carboxylic acid part of the ester, and in this case that means there's a 5-carbon chain, it's part of an ester, and there's a 4 bromo group at carbon 4. Well, let's go. Let's do this. Let's throw in an alkene, just for the sake of argument. What would the name of this be? Well, again, I would start with what is the alkyl group name for the alcohol part. Okay. If you said this is a sec-butyl group, you are correct. So this is going to be sec-butyl, and now we need to work on the carboxylic acid part of the ester. So in this case, we start numbering here. That automatically gets the number 1 position because it's on the high side of that chart. And now I would do this. So now there's a methyl group here as a substituent at carbon 4, but now I have a double bond. So again, this would be a pent. Now, if it's a pent and O8, that means there's no double bonds, and the carbon chain is an alkane chain. So this would be a pent. Where is the double bond located? 3, and the pentene with an E or not, I'm not that's a really minor detail, but there is actually no E when you use it in between, but I'll just put it in anyway. So this is a pent 3-ene, and then we drop the AN, and now we would say, actually we would call this a pentene 08 with no E there. So just a couple things about that. Whenever you can't have an E with an E next to an O in an IUPAC name. So for instance, if it was an ene or an ine, you would drop the E and just bring in the OATE. Now you might be saying, okay, I get it's a pent, that's 5 carbon chain, and actually we should have, and actually this should be a 4-methyl pent, and then the sec-butyl before it. So it's a sec-butyl 4-methyl pent. I get the fact that there's a 3-ene, but why isn't it like 1 OATE? And the reason that we just combine the ene or the an and the OATE together is because it's understood by the rules that the carboxylic acid part or the carbonyl part or the C double bond O part is always number 1 in the numbering scheme, so we don't need to include that. So if there's a double bond in here, it would be a number with an ene08, and then if there is just a straight chained or a series of carbon-carbon single bonds, it's an ANOATE. It's not necessary to include the number 1 before the OATE because it's automatically understood that that carbon gets the number 1 numbering. Okay, let me throw up one here. Let's do that. Okay, so if you want to try and name this, if you want to stop the video, try and name it, and then come back and see if you got it right, you can do that. If not, I'll walk you through either way what the answer would be. So the first step is we need to name this alkyl group. So this is a butyl group with an iso in it, so that is isobutyl. So this is going to be isobutyl something. Now let's look at the carboxylic acid part of the ester. Automatically start numbering here. 1, 2, 3, 4, 5, and we should number this with the longest chain that includes the triple bond, since the triple bond has some priority, although again it doesn't beat the ester. So we've got a 7 carbon chain, and so this is going to be a hept. We have a chlorine at 3, a bromine at 4, and a methyl group at 5, along with then the triple bond at carbon 6. So let's put together our substituents. So this would be a 4 bromo, 3 chloro, 5 methyl, and now we're ready for the parent name, which the parent name of this carboxylic acid part is 7 carbons, so that means it's a hept. It's got a triple bond in it, So this one's going to be a hept 6-ine-O8. So the 6YN, and again, there's no E because the E and the OATE are not compatible. So we take the E off of ene and ine when we add something with a vowel on it. So the 6-ine means there's a triple bond between carbon 6 and 7, and the OATE is the suffix for the carboxylic acid part of the ester. So this is the group that's attached to the oxygen that came from the alcohol part, and then this is the name of the rest of the molecule that came from the carboxylic acid portion of the molecule. This group came from the alcohol. Sorry, that's the group attached to the alcohol part. Okay, so that's kind of a not so. I guess it's a little longer, but that's how we would name esters. Is alcohol part first, then carboxylic acid part second, with an OATE ending, with either an ene O8 for a double bond if a double bond was there, an ine O8 if there was a triple bond there, or an OATE if it was just carbon-carbon single bonds.